Metallurgy. The various steps involved in extraction of metals from their ores and refining them for use is called metallurgy. The various steps involved in the extraction of metals are concentration of the ore, conversion of the concentrated ore into metal oxide, reduction of the metal oxide to metal, and refining of the metal. Metallurgy is the process of extracting metal in a pure state on a large scale from its ore by physical or chemical means. Physical means include crushing and concentration. Chemical methods include roasting, calcinations, reduction, and refining. Concentration of ore. The process of removal of impurities from the ore is called concentration of ore. There are various methods employed for the concentration of ore depending upon the nature of the ore and the nature of the impurities present. For concentration, the ore is first crushed in jaw crushers and then finely powdered. The powdered ore is concentrated by a suitable method. The various physical and chemical methods of concentration of ore are hydraulic washing, gravity separation, froth flotation, magnetic separation, chemical separation or leaching. Hydraulic washing, gravity separation. This method is used where the gangue particles are lighter than the pure ore particles. In this method, when the powdered ore is treated with a stream of running water, the light gangue particles are washed away and the heavier ore particles are left behind. For example, the ore of tin cassiterite SnO2 is purified by this method. Froth flotation. This method is based on the preferential wetting of the ore by oil and gangue by water. It is used for the concentration of sulfide ores which are lighter than gangue. In this process, the finely powdered ore is mixed with water in a large tank. A small amount of oil, example pine oil, and a froth-producing reagent, example amyl xanthate, are added to it. Sulfide ores are wetted by pine oil and gangue particles by water. The whole mixture is agitated violently by passing air through it, and froth is produced. The froth is skimmed off, washed and dried. The gangue particles, being heavier, sink to the bottom of the tank. Magnetic separation. When either the ore particles or the impurities are magnetic, they can be separated by means of a magnetic separator. The finely powdered ore is dropped over a magnetic belt which passes over the magnetic ruler. Example, rutile TiO2 is concentrated by this method. Leaching. In this method, the powdered ore is treated with a suitable solvent in which the ore particles alone dissolve and the impurities are left undissolved and can be removed by filtration. Bauxite is purified by leaching with caustic soda. Conversion of concentrated ore into suitable form. After concentration, the ore is generally subjected to calcination and roasting depending upon the nature of the ore. During calcinations and roasting, the ore changes into oxide. Reduction of metals. The process of obtaining metals from their compounds is called reduction. Metals low in the reactivity series can be obtained first by heating their compounds. reduction by heating, reduction with carbon, reduction with aluminium, reduction with magnesium, reduction with hydrogen, electrolytic reduction, reduction by heat. Some less electropositive metals can be directly obtained by roasting their sulfide ores, followed by distillation. Example, mercury can be obtained by roasting cinnabar. HGS, cinnabar, plus O2, oxygen, gives Hg, mercury, and SO2, sulfur dioxide. Reduction with carbon. The process of reduction of compounds with carbon is known as smelting. In this process, the roasted or calcined ore is mixed with suitable quantity of coke or charcoal, and it is heated to a high temperature above melting point. During the reduction, an additional reagent is added to the ore. This additional reagent is called flux. Flux combines with the impurities to form a fusible product called slag. Metals like zinc, iron, tin, lead, etc. are extracted by this method. For example, tin stone SnO2 is reduced by coke. Tin oxide SnO2 plus carbon 2C gives tin Sn plus carbon monoxide 2CO. Coke is an important reducing agent in metallurgical processes because of the following reasons. It can reduce majority of oxides. It is cheap and abundantly available. Reduction with aluminium, thermite process. Reduction with aluminium. Certain metal oxides such as chromium oxide and manganese dioxide are not easily reduced with carbon. In such cases, aluminium is used as reducing agent because it is more electropositive than chromium or manganese. The process of reduction of oxides with aluminium is called aluminothermy. Example, Cr2O3 chromium oxide plus 2Al aluminium gives Al2O3 aluminium oxide plus 2Cr chromium. Reduction with magnesium. Sometimes magnesium can reduce compounds. Example, titanium tetrachloride is reduced by magnesium to form magnesium chloride and titanium. Titanium tetrachloride TiCl4 plus 2Mg magnesium gives 2MgCl2 magnesium chloride plus Ti titanium. Reduction with hydrogen. Reaction with hydrogen. Hydrogen is very efficient reducing agent. The roasted ore is heated in small trays in the current of hydrogen gas. WO3 plus 3H2 gives W plus 3H2O. Tungsten oxide, when heated in the current of hydrogen gas, gives tungsten and water. Electrolytic reduction. Strong electropositive metals are extracted by the electrolysis of fused chlorides or fluorides of them. In order to obtain these metals, their salts are electrolyzed in fused state. The commonly used salts are halides. For example, sodium metal is extracted by electrolysis of molten sodium chloride. The chlorine gas is liberated at anode, the positively charged electrode, whereas sodium metal is liberated at cathode, the negatively charged electrode. The overall reaction may be represented as 2NaCl, sodium chloride, on electrolysis gives sodium Na plus chlorine Cl2. Get Doubtbox on a device of your choice. We have education tablet, pen drive for PCs, SD card, smart TV apps and online versions available. Register today for a free trial and experience the new way of learning.